I think maybe what we'll do for the sake of time is go right to Khaled, and then we'll have a discussion afterwards. So Khaled?
Good morning. I want to share with you in general some of the strategies that we have or we could implement when we have limited water supplies as we're facing in California. So with this presentation, I'm going to present, the first maybe about half of the presentation, talking in general in California, and then I will switch over to Ben Faber, who can talk about water strategies specific to avocado. So we already know about Sigma, and Ben done a great job giving us the background for Sigma. And as you know, in California, sometimes we have wet years and sometimes we have dry years. And this is a good example between, February 2019 and February 2020. This is from the LA Times. And you could see 2019 was a wet year, 2020 was a dry year. And now with the climate change, even when we have a wet year, we have runoff. And that runoff comes earlier because of climate change and, changing weather conditions. So when you look at the state of California, most of the water supplies are in the north. You can think of north of Sacramento, but most of the demand are in the Central Valley and Southern California. So typically, if we have a normal year, which is very hard to have a normal year, most likely we don't have a normal year. It would be either on the dry side or the wet side. But if we have a normal year, we'll have runoff coming, and that runoff will supply the reservoirs, and then that system will be used for irrigation. And then we can use groundwater for irrigation to supplement, the surface supplies. Now in dry years, we have to go to groundwater, and this is why we have, the issues with groundwater in California, and the reason we have Sigma. If you look at the future, looking at 25, 30 years from now, and there are so many climate models predicting what will happen with the Sierra snowpack. And in general, these are different models here, predicting what will happen to, the snowpack and how much surface runoff that we'll have available. In general, we're looking at about maybe 25% reduction in the amount of water coming from the Sierra Nevada mountains. As you know, California agriculture is big. Typically, we're looking at about $50 billion, $55 billion industry. And we have to have water for irrigation. We cannot just depend on rainfall. So what can we do in general? So we have to look at management practices to reduce waste. Because, if you have limited water supply, you want to improve efficiency. So we can look at ways to reduce waste. We have to look at strategies that can stretch the amount of water available for irrigation. And, just some of the basic strategies include irrigation scheduling, knowing how much water we need to apply when we irrigate and how often we need to irrigate. And there is a trend also looking at variable rate irrigation. And with variable rate irrigation, like let's say I have a 20-acre field. Typically, if I have one irrigation zone, I would be applying more or less the same amount of water for, everywhere in my field. Now, if I have variable rate irrigation, I could take this field and look at variability that I have in the field and I apply the right amount of water for each location. We can look at automation. Automation will help in water conservation and also with labor. As you know, labor cost is relatively high in California. So in this example, you could see, a field. This is an almond field that we have in the Central Valley. And you could see this is just an illustration of the canopy cover. The darker areas, we have larger, bigger trees, and the lighter areas right here, the light green is relatively smaller trees. So if I have one irrigation zone, which was the case for this field, I'm just turning the water on and I'm applying the same amount of water for the entire field. In a situation like this, if I want to improve efficiency and deal with limited water supplies, I could divide this field into zones, and I can apply the right amount of water for each zone. If you can look at the type of irrigation systems that we have in California, in general, back in the 1970s, flood irrigation used to be the dominant form of irrigation system. And if you look at what's going on over the last 20 years or so, this is drip irrigation. You can see right now, and actually this is the data from a few years ago, we have about 50% of the irrigation systems in California drip irrigation. Typically with the drip irrigation, you have higher irrigation efficiency. And I can see this trend will continue, especially with the incentives that are provided by CDFA and other agencies to conserve water and energy. So, the low-hanging fruit, like, if I have a field and I want to, just do quick and easy measure to conserve water, I would just look at, looking at my irrigation system and how I can improve efficiency. So the DU would be the low-hanging fruit, looking at distribution uniformity in my field. And that test, it's not difficult to do, and it could take maybe less than half a day. And that will give you an idea about my current irrigation system and what I can do to improve efficiency. So that will make a big difference. Now, in certain areas, depending on the soil type and availability of surface water, we could do groundwater recharge during wet years. And that will help us to conserve water and store it in the ground. Ben also mentioned about reuse of recycled water. That is also one way where we can stretch the amount of water that we have available. And that cannot be for all the crops. We have some crops in California that they're tolerant to salinity, and we could use treated wastewater for irrigation. We can also look at technologies to take the drainage water and remove or reduce the amount of salt in it, so we could use it for irrigation. Right now, over the last 7-8 years, we have the SWEEP program from CDFA, where farmers can apply for water and energy conservation projects. And right now, they can get up to $200,000 per project to improve irrigation efficiency and reduce the greenhouse gas emissions. So some of these programs, somebody could look at existing irrigation system and try to move to a more efficient irrigation system. You could see here also improvements in water delivery whenever you have irrigation district. Typically in the old days, you have to order water a day or 2 days before the irrigation event. And then you have to tell them in advance how much you need, how many acre feet. Now with modern technology, we could make these things simpler and have water on demand. The farmer, in this case, this is also in the Central Valley. The farmer, they can go to the gate and dial in how much water they need. So it's similar to what you have at home. You have water on demand. This is right here in the middle picture. This is an example on almond field in the Central Valley in Hanford. This is where we implemented variable rate irrigation and basically dividing the field into smaller zones as small as 1 acre, where we can implement, different irrigation strategies based on the canopy coverage and the soil type. And this is an example also. The third example here is for flood irrigation, where we can do automation of flood irrigation, and we can conserve both water and labor. So these are also other examples, drip irrigation. We talked a lot about drip irrigation. Subsurface drip irrigation on field crops, that's also another option. And that's commonly used on alfalfa, cotton, and some other commodities. You could see here also a drip irrigation for growing lettuce, and sprinkler irrigation or linear move system. There are lots of technologies in the market right now that help us in making good estimates of crop water requirements. And these are examples of, arable technologies and Thule technologies. And basically they can tell you the actual evapotranspiration of the crop in your area. So in general, when we improve efficiency, there are consequences. Consequences of improving efficiency would be, salinity buildup, because if we're not applying enough water to move salts, we may have salinity buildup, and that depends on the water quality that we have. We have less water for recharge. Over irrigation sometimes doesn't mean, it's a waste of water. That extra water could go to groundwater recharge, but then we may have issues with the water quality like nitrate. Increased cost. Whenever we apply additional water than what we need, we're spending money on the water cost and also spending money on energy. So typically, for any crop, avocado or any other crop, the easiest and simple way to look at improving irrigation efficiency and trying to determine how much water I need to apply. And this is just a simple equation that I'm sure all of you are familiar with, where we say the crop coefficient, the crop water use basically is the reference evapotranspiration times the crop coefficient. And we can calculate the crop water use based on the ET in our region, the reference evapotranspiration, and then the specific crop coefficient that we have for the crop of interest, and in this case, avocado, and I'm gonna show you some example. But the key point here is whenever we calculate the crop water needs, we have to consider the irrigation system efficiency. So we take that number and divide it by DU, the distribution uniformity. So if we have high distribution uniformity, applied water will be very close to the ETC or the crop water requirements. If we have low DU, then we have to apply additional water to meet the crop water needs in the entire field. And you can see here example of the system, different irrigation systems, and the distribution uniformity. I want to emphasize this is the easiest way to improve system efficiency by looking at the distribution uniformity. And if the distribution uniformity is lower than the numbers that you see here in this table, that's a good indication that the irrigation system needs to be improved. And so we can get higher DU, which means we're saving water and saving energy. When we calculate crop water requirements, basically what we're doing, we're taking the reference evapotranspiration and the crop coefficient, and we come with the crop water use. But we have to keep in mind, like Ben mentioned, there are about 150, 60 CEMIS stations all over the state, and that's where we get the reference evapotranspiration. But that crop water requirement is for healthy, mature tree, if we're talking about avocado. In reality, if you have a sick tree or your canopy coverage is not the optimal, we have a stress factor, which basically the actual crop water use is typically less than the ETC. So we have to keep this in mind, when we calculate the crop water requirements. In the old days, we used to have maps, for reference evapotranspiration, and those were really handy. You could see for like avocado growing region, we have different zones like 3, 4, and 6. That's the ET zone. And you can, look at average ET for that region, and this is a good starting point. But right now, things are easy. We can just go to the CEMIS website. CEMIS is the California Irrigation Management Information System. I can just go there, click on my farm, and get an idea about the ETO for my location based on the current information. And I can sign up. This is an example. You can just go sign up, click on the map, sign up, give them your email, and they will send you an ET report every Monday. And this comes handy, like I get an ET report for the farms that I'm interested in every Monday. And then I can use that information to make, good decisions when it comes to irrigation management. So the ETO, basically, that I get from CEMIS, it depends on the weather. It's the amount of water used by unstressed grass, but it's basically weather data like solar radiation, humidity, temperature, and wind speed. That will go into an equation that will give me the reference evapotranspiration. The KC that I get for avocado in this example depends on so many factors, mostly related to the crop, the light absorption, canopy coverage, roughness, physiology, the age of the tree, but also it depends on environmental factor like the irrigation system. So if I have a drip irrigation system, my KC would be different than if I have a micro sprinkler or flood irrigation. So we have to keep this in mind. This is a good starting point, but then we have to make adjustments based on, the locations that we have. There are lots of information about crop coefficient for avocado, and this is a table from UC Riverside, the work that has been done over the years. But a good way to look at KC, and I like to keep things simple, for avocado in this area, in general, in California, the KC, you can estimate KC from the fraction of the shaded area of the tree. So you can just say, okay, my KC is 86% of the fraction of the shaded area. So if my shaded area is 90%, so all I have to do is just multiply 0.86 times the fraction of the shaded area. So you could see the numbers in California, they're relatively on the low side, 0.65, that's the maximum KC. Now, these are some numbers from Australia. And, you can think about, the season is different. So you could see the crop coefficient as high as 1. That's during their summertime. But these two pictures that I got when I visited Ben a few years ago, looking at different orchards. You can see on the top here, I have almost 95% shaded area. Down in the lower picture, I have, relatively small shaded area. So definitely the crop coefficient, when I have higher shaded area would be a lot different than if I have smaller shaded area. So I will stop now and turn it over to Ben to talk about specific strategies for avocado under limited water supplies. Thank you.
Yeah, so I was out in an orchard about 2 weeks ago, and of course we're talking disease and management and insect pests and stuff like that. And I asked the grower, well, what's wrong with your irrigation system? The grower said, oh, there's nothing wrong with my irrigation system. And I said, well, listen, you know, some of these spinners are going bzzz, and some are going bzzz. And then look over there's a twig that's stuck inside the spinner. It's not even spinning. It's just shooting out a constant stream in one direction. And it's like, when did you last look at your irrigation system? And, you know, all too often it's sad. These are tinker toys we have out there, and they've got to be maintained all the time. And I would say that our industry is pretty darn lax when it comes to maintaining the irrigation systems. And we have these resource conservation districts out there that will do an evaluation for free on a yearly basis. And how many growers use this service to determine the quality and how effective their system is? I would say less than 10%. You know, it's you know, if Khalid has talked about saving water and saving energy, the system is spraying out water and it's hitting the trunk, and it's just dripping down there, and it's wetting that trunk, and the tree right next to it is not getting anything. You know, how do you decide what's going to be a healthy tree? Because you don't know how much water is being put out. So doing a DU on your irrigation system is critical. And that really is, you know, you cannot manage water until you've got a meter on your system, and you can't manage water until you've got a good handle on what the water is being put out. And then we talk about CIMMYS. CIMMYS can help you identify when and to apply water. You know, running a schedule every Monday from 7 till 7 o'clock on Tuesday just does not cut the mustard. It's either over irrigating or under irrigating at any one time. It's never hitting it, what the tree's needs are. So a healthy tree is really a function of what water it's getting. So we have this outbreak of botrytis, leaf blight, and all that stuff. That's just mismanagement on the part of the grower. You know, if you don't have a good distribution system that's managed to meet the needs of the tree, you're going to have tree blight, you're going to have root rot. These are opportunistic diseases that are looking for water mismanagement. So Khalid also talked about the water requirement of the tree as a function of the amount of leaves that are out there. If you've had frost damage or heat damage and you don't have any leaves on the tree, you don't have any water use by the tree. As the tree gets bigger and bigger, it uses more water. And if you want to reduce water use in an orchard, you stump the orchard so there aren't any leaves on it anymore. Or if you've got an overgrown orchard like Khalid showed in Australia, which is not the most efficient light interceptor. It forces flowering to go up to the top of the canopy, and you don't have any production lower down. You can actually improve yield by reducing canopy size so that light is intercepted on all sides of the tree. Reducing tree size, you actually reduce water demand as well, water use by the tree. So can be a very effective way of reducing water use in an orchard. And then, you know, this variable irrigation, you know, when you get an orchard and you're going up a slope and you're going down the slope onto the dark side of the orchard. So if you're farming a south side and a north side of an orchard, the north side's going to use less water than the south side. You know, in the wintertime, it's going to get less sun. Top of the slope, it's going to get more wind. The bottom of the slope is going to get more drainage from above the slope, and it's also going to get less wind. So blocking irrigation, even on a 20-acre orchard, is critical. You know, all too often, the valve that turns water on to the north side, the south side, and the top of the hill and the bottom of the hill, they all get the same amount of water. You have different size canopies. You're going to over-irrigate some parts, you're going to under-irrigate others, and you're going to have a diseased orchard. So this idea of putting in a valve and you monitor soil moisture according to the needs of that tree is critical for a healthy orchard, but you can actually save a large amount of water to irrigate according to the plant needs. So I don't think I can move this forward. Can you move it? Yeah, so prune. So you don't, if you cut out half a tree, you don't reduce half the amount of water, but you'll reduce it by 20 or 30%. So it's also increasing light penetration into the canopy. So you'll get flowering and fruiting more throughout that canopy than if you have this canopied out. I mean, it used to be so common out there, and until we got avocado thrips and we started spraying pesticides, and we didn't get good penetration until we pruned. A lot of orchards were just overgrown. So we're seeing more pruned orchards now than we saw before. It also increases airflow and reduces disease problems in fruit, like anthracnosis and alternaria. So next slide. Khaled, you're not listening to me. Ah, there it is. So this was Khaled's. You fell asleep, I know you. So this, you know, this idea that there is variation within the field, within the orchard, within the grove. Yeah, you can block this. You can block it, and boy, it's so much easier in an avocado orchard where you have these very distinct positions on a slope that use more or less water. I mean, if you're in the Central Valley and it's all flat, you can't see the variation that exists in the soil, and so you really have to cruise a large area to figure that out. You know, avocado growers in Southern California on slopes, you can see it. You can stand back on the freeway and look back and go, oh, that's where I need to block this irrigation. So blocking irrigation can significantly change how water is used in an orchard. Next slide, please. If you think of water use as water used during a drought, avocados are not adapted to hot, dry climate. In fact, Gary Bender was hired to go to the Middle East to evaluate plantings of avocados in Saudi Arabia. Well, they don't grow in a dry environment like that. They won't grow in Palm Springs. It's too darn dry. They like this coastal environment. They like more moderate environments. They've got a shallow root system, so they've got to be irrigated according to the needs of the top 8 inches or so, and they have a low salt tolerance. Next slide. So look at your orchard. We're talking about you've got limited water, you've got expensive water. How are you going to use that water? So you've got this sensitive crop. It's prone to root rot. It doesn't like windy positions. It doesn't like positions that are wet. So why bother to grow the tree there? So figure out, looking at your orchard, where am I putting water that I'm not getting a return? where are my trees not doing well? I got to be really a business person here. I've got to decide, where am I losing money? Where am I making money? And decide, okay, I'm going to cut out this orchard, or I'm going to cut out this part of the orchard. Where do I have a high soil pH and I've been fighting this iron chlorosis? Where do I have problems with excess salinity? Where are the soils really too shallow to effectively grow avocados? I mean, we can grow avocados where goats can't go, but maybe we shouldn't be doing it. So, analyze the orchard and decide, works here, this does not work there, and just shut the water off, cut the trees down, don't turn it into a fire hazard, get rid of them. So set priorities, irrigate the productive blocks, and fix that darn irrigation system. They keep falling apart. And you need to be walking this system. We've got coyotes out there, we've got gophers, we've got rabbits, we've got pickers, we've got pruners. These things get jammed, banged, doomed to destruction, and you got to fix them, and you got to evaluate them for clogging and breakage. I'm onto my high horse here. Okay, next slide, please. So we've got a lot of information out there. Nobody reads it, but if you really get into it, we've got a blog that comes out 3 times a week or so. We've got a newsletter that comes out quarterly, covers a lot of issues. You can go into those issues. You can go into, those newsletters and the blogs and type in search engine. You can kick out a lot of information about managing avocados in droughty and situations. So I think that's it. Oh, summary, okay. So you want to look at, you've got limited water supplies. What do you do? So fix your irrigation system. The DU is really critical to everything you do out there. You can't mess around with deficit irrigation. This has been shown time and time and time again. If you've got X amount of water on Y land and you can't cover all that land to the needs of the tree, you got to reduce the amount of land that you're irrigating, the amount of trees you're irrigating. Stressing all the trees is not going to be productive. So figure out what part of the orchard is going to be productive with the amount of water that you've got, with the amount of water you want to spend, and just irrigate that. Automation helps. It's no replacement for the human being. You need to be out there, but lots of soil moisture monitoring devices out there that you can use, especially with the Wi-Fi systems that are out there. You sit in your office and see what the trees are doing. You still got to go out there and walk it. You got to make sure that the system is working right. So use the latest technologies, and don't forget about the old technologies. Shovels are great. Improve the irrigation system efficiency and flexibility. Try to be on demand if you can. There's still a lot of orchards that are getting water deliveries, whether they want it or not, on a Wednesday. So it's hard to schedule irrigations. If you can build in some kind of storage with tanks or with ponds, do that, so that you can irrigate according to plant need, not according to water availability. Use any sort of programs out there like SWEEP, CDFA, like the NRCS's EQUIP program to improve your irrigation systems. There are some programs out there, some of the Sigma management agency plans that are looking at groundwater storage, and if you can, get in on those systems to improve groundwater storage. So that's it. Khaled, anything else?
No, you covered everything.
Everything. Oh my goodness. So we can talk now.
Very good. Well, we have, thank you, Ben and Khaled. We have no questions right now in chat. So does anybody have any questions? You can raise your hand and we'll be happy to have a discussion.